Hello everyone, welcome back to the channel. In our last episode, we mastered args, kwargs, and lambda functions. But today, we are facing the final bosses of Python functions. If you want to transition from a beginner to a professional developer, you must understand decorators, recursion, and generators. These topics might seem intimidating at first, but don't worry, we'll break them down together, step by step. First, we have decorators. A decorator is a function that executes another function by wrapping it. It takes the function you want to run as an argument. In Python, a decorator allows you to add functionality to an existing function without modifying its source code. You can apply it easily using the @ symbol. In this example, I've created a wrapper called changeCase to uppercase the string returned by the decorated function. You can use this logic to uppercase or lowercase any string. When I call the main function, the wrapper runs first, applying the logic to the wrapped function without changing its original source code. You can also execute code before and after the wrapped function runs. Here, I've added two print statements for before and after the execution. But what if your function needs arguments? If your wrapper doesn't accept them, your code will crash. To make a decorator universal, we use *args and kwargs. This way, it can wrap any function regardless of its signature. As you can see, I'm using a special syntax here that I'm introducing for the first time on this channel, func.double_name_. It's a property that gives you the name of the function being used. I'm also using f strings, by adding f before the string and using curly braces, to combine text and variable values easily. Sometimes, the decorator itself needs options. To achieve this, we add 3 levels of functions. This is called a decorator factory. To keep it simple, in this example, the code will execute the wrapped function multiple times based on a times variable you provide. One important reminder, if you use decorators but don't return the internal functions, your code will throw an error. Here, we must return 2 things, the decorator, the definition, and the wrapper, the actual code block being executed. If I remove any return statement inside these blocks, it will fail. Next, we have recursion. This is when a function calls itself. It's elegant, but it can kill your RAM if you forget the exit strategy. Every recursive function must have 2 parts. Without a base case, you'll hit a Stack Overflow just like in this code. When executed, this function calculates the factorial of any positive number. If I call it with 5, it calculates 5 times open parenthesis 5 minus 1 close parenthesis and continues until n equals 1, then starts returning the values. If I delete this base case, the function will run until you run out of RAM or the IDE stops your code. For instance, VS Code stopped mine after 1000 calls. Recursion makes your code shorter and more elegant, but it can be harder to understand, slower due to function call overhead, and more memory intensive. Personally, I prefer loops over recursion, but in some situations, like binary trees or graphs, loops are actually more complicated to solve than recursion. Pro tip, you can check the current recursion limit or set a new one using sys.getRecursionLimit and sys.setRecursionLimit. Just make sure you know what you're doing before changing these. Lastly, we have generators. Generators are functions that can pause and resume their execution. When you call a generator function, it returns a generator object, which is an iterator. They are defined like normal functions, but instead of return, they use the yield keyword to produce values one at a time. Each time yield is encountered, the function state is saved and paused. When the next value is requested, it resumes right where it left off. You can interact with a generator using next to get the next value, send to pass a new value into the generator, close to terminate the generator safely. In this simple example, I created a function with 4 yield statements. Each time I call next, it moves to the next step and pauses. It can be described with this animation. When using send, you can assign a variable to the yield expression. If the program is paused at yield 1 and I send a new value, that value is assigned to the variable, and I can print it out. Finally, you can use a try finally block to get a notification when a generator is closed. I've wrapped the code in try and used finally to print a generator closed message. We've defeated the 3 bosses. Decorators to upgrade your logic. Recursion for self-calling beauty. Generators for memory performance. But as you saw, with great power comes great responsibility. One wrong move with recursion and your program crashes. That's why in episode 8, we're going to learn how to defend our code with error handling, try except, and how to save our data permanently by working with files. You don't want to build a cool program only for it to crash on the first error, right? If this video helped you, hit like and subscribe to support the channel. See you in the next one. Happy coding!